So let's take a look at compound angle formulas. Here are the list of the compound angle formulas that you will use in this unit. In the next video, we will derive all these formulas. But for now, let's take a look on how to use these compound angle formulas. So we already know how to determine exact values for any angle that has a related acute angle of 0, pi over 6, pi over 4, pi over 3, or pi over 2. With these compound angle formulas, we will be able to determine exact values for angles made by adding or subtracting two angles that have a related acute angle of pi over 6, pi over 4, pi over 3. So let's look at how we can do that. So for example 1, determine the exact value for the following trig ratio, sine of 7 pi over 12, which we notice does not have a related acute angle that's equivalent to pi over 6, pi over 4, or pi over 3 in the form that it is written. So the first step for questions like this is to split up 7 pi over 12 into two angles that have a related acute angle of pi over 6, pi over 4, or pi over 3. And again, it's just guess and check. So I could try 5 pi over 12 and 2 pi over 12. Well, 2 pi over 12 gives me pi over 6, but 5 pi over 12 still leaves me with a denominator of 12. So let's try a different set of numbers. What about 3 pi and 4 pi? Well, those reduce to pi over 4 plus pi over 3. And these are two angles that we can work with. So step 1 is to rewrite our expression. So therefore, sine of 7 pi over 12 is equal to the sine of pi over 4 plus pi over 3. So going to our compound angle formulas and looking at sine of A plus B, this is the same as sine of pi over 4 times the cosine of pi over 3 plus the cosine of pi over 4 times the sine of pi over 3. Next, we need to look at our special triangles. So we have 1, 1, and root 2. That deals with our pi over 4. And next, we have our 1, 2, square root of 3 triangle, which deals with pi over 3 and pi over 6. So all we need to do now is sub in our values. So sine of pi over 4 we know is 1 over root 2. Cosine of pi over 3 is 1/2. Plus cosine of pi over 4 is 1 over root 2. And sine of pi over 3 is root 3 over 2. To ensure that we don't have a radical in the denominator, I'm going to rewrite root 1 over 2 as root 2 over 2. Next step is to multiply, so I get root 2 over 4 plus root 2 times root 3 over 4. And the last step, you can factor out the root 2, which leaves me with 1 plus the square root of 3, since both terms are over the denominator of 4. And this would be the exact value of sine of pi over 4 plus pi over 3, or sine of 7 pi over 12. All right, let's go to our second example, cosine of 11 pi over 12. First step, let's split up 11 pi over 12. And again, you can guess and check, but I find the best is 3 pi over 12 plus 8 pi over 12. Again, we want to get a denominator of 4, 3, or 6. So 3 pi over 12 will give me a denominator of 4, and 8 pi over 12 will give me a denominator of 3. So cosine 11 pi over 12 is equal to the cosine of pi over 4 plus 2 pi over 3. Using our compound angle for cosine, we get cosine of pi over 4 times cosine of 2 pi over 3, then minus the sine of pi over 4 times the sine of 2 pi over 3. So again, let's look at our special triangles. An example we need to focus on is the cosine of 2 pi over 3 and the sine of 2 pi over 3. So all we need to note for this is that 2 pi over 3 is in quadrant number 2. There's 2 pi over 3, and it has a related acute angle of pi over 3. So we're going to adjust those. So we have cosine pi over 4. Cosine in quadrant 2 is negative, so this would be negative cosine, and the related acute angle is pi over 3, minus sine of pi over 4, times, since sine is positive in quadrant 2, then this becomes the sine of pi over 3. So this gives us negative cosine of pi over 4 times the cosine of pi over 3 minus the sine of pi over 4 times the sine of pi over 3. Now let's determine our ratios. So this is negative. I'm going to go right away to root 2 over 2. Cosine of pi over 3 is 1/2 minus the sine of pi over 4 is root 2 over 2 times the sine of pi over 3, which is root 3 over 2. Let's try to simplify this. So I get negative root 2 minus root 2 times root 3 all over 4. And if we common factor, if we take out a negative root 2, I'm left with 1 plus the square root of 3 all over 4. And that is what cosine of 11 pi over 12 is equal to without using a calculator. Next one, pi over 12. This one we're going to need to subtract two angles. So again, it's guess and check. But 4 pi and 3 pi over 12 will give us 1 pi over 12. And note, again, they reduce to pi over 3 and pi over 4. We're looking for denominators of 3, 4, or 6. So tan of pi over 12 is equal to tan of pi over 3 minus pi over 4. All right, now we need our tan identity. So this is going to be tan of pi over 3 minus the tan of pi over 4 over 1 plus the tan of pi over 3 times the tan of pi over 4. So using your special triangles, tan of pi over 3 is going to give us the root of 3. Tan of pi over 4 will give us 1. And then we get 1 plus the tan of pi over 3, which is again is root 3, and then times 1. So this is equal to root 3 minus 1 over 1 plus the square root of 3. And now normally you would say you are done. So if you finish there, that's great. But I'm going to show you how to simplify this further. So you have root 3 minus 1 over 1 plus the square root of 3. We want to get an integer value for our denominator. And to do that, we're going to multiply by what's called the conjugate of the denominator. So I'm going to multiply by 1 minus the square root of 3 in the top and in the bottom. If the bottom was 1 minus root 3, then I'd multiply by 1 plus root 3. And let's see what happens. So in the top, if I use my distributive property, I'm going to multiply root 3 by 1 and then by root 3. And then same thing, 1 by 1 and then 1 by root 3. Therefore, in the numerator, I get root 3. Then root 3 times negative root 3 is minus 3. Negative 1 times 1 is minus 1. And negative 1 times negative root 3 is positive root of 3. In the bottom, doing the same thing, I'm going to get 1 minus root 3 plus root 3 and then minus 3. So let's simplify the top. I get negative 4 plus 2 root 3's. And in the bottom, notice these root 3's equals 0, which is how we get an integer value in the denominator. So we get minus 2. Let's factor out a negative 2 from the numerator. So I'm left with 2 minus root 3 all over negative 2. And notice now we end up with 2 minus the square root of 3. And therefore the tan of pi over 12 is equal to 2 minus the square root of 3. Alright, last couple of examples. This one just says simplify. That means bring it down to one term. And now that we see that there's a cos times a cos, we should look at our cosine compound angle formulas. And since there's a plus, we're looking at cosine A minus B. So this is equivalent to the cosine of A minus B. And we can take this a step further. This would be pi over 6 minus 2 pi over 6, which gives us cosine of negative pi over 6. And since cosine is odd, this is the same thing as negative cosine of pi over 6. And example 3. You're given that the sine of one angle is equal to 3/5. The sine of a second angle is equal to negative 7 over 9. We know that both angles are obtuse, and we are told they are in quadrant number 2. So from pi over 2 to pi, determine the exact value of cosine theta 1 plus cosine theta 2. So we're going to try to do this without a calculator. So cosine of theta 1 plus theta 2. So we go to our compound angle formula. So we have cosine theta 1, cosine theta 2, minus sine of theta 1, sine of theta 2. Right now, all we know is cosine of theta 2 and sine of theta 1. So how do we get the other two ratios? So let's start with sine of theta 1. So sine of theta 1 is equal to 3 over 5, which is equal to the y over r. So if I want to find the x value for this using Pythagorean's theorem, I see that x squared is equal to 5 squared minus 3 squared. If we solve for x, we get a value of plus or minus 4. But since we're in quadrant number 2, this means that x is equal to negative 4. That now tells us that cosine of theta 1 is equal to, remember that's x over r, is negative 4 over r, which is 5. So remember that's x over r. So now we have cosine of theta 1. All we need is the sine of theta 2. So to determine that, we start with the cosine of theta 2, which is equal to negative 7 over 9. Again, that's x over r. If we draw that out, there's negative 7, there's 9. We need to find the y value. So y squared is equal to 9 squared minus negative 7 squared, which gives us that y is equal to the square root of 32. But then we need our plus and minus. In quadrant 2, that means I only need the positive, so y equals positive 32. Since we are in quadrant number 2, y is positive. And we can reduce that to, since that's root 16 times root 2, this is 4 root 2. So now we can state the value for sine of theta 2. And sine of theta 2, which is y over r, is 4 root 2 over 9. Remember, that's y over r. All right, so cosine of theta 1 plus theta 2. So cosine theta 1 is negative 4 over 5 times cosine of theta 2, which is negative 7 over 9, minus sine of theta 1, which is 3/5, and sine of theta 2, which is 4 root 2 over 9. So we end up with 28 over 45 minus 12 root 2 over 45, which tells us that the exact value for cosine theta 1 plus theta 2 is equal to 28 minus 12 root 2's over 45. And now we are done. Try the following questions, and good luck.